Section 4.4, corresponding parts of congruent triangles are congruent. So we're introduced to the idea of CPCT, or as the book also refers to it as CPCTC. Just means that corresponding parts of congruent triangles are congruent. All right? So basically what this means is when we prove two triangles congruent, we can then continue the process of proving other pieces of those triangles congruent using CPCT as our reasoning. In order to use CPCT in a proof, you must first prove that the two triangles congruent. So this particular designator won't show up until the end of your proof, either at the very end or one of maybe the last few steps. It's not to be used in the beginning of this proof before you've proven the triangle's congruent. So in this proof, we're given that angle KBC is congruent to angle ACB, and angle K is congruent to angle A. So we start our proof off there. But notice here they're asking us to prove that the two segments KB and AC are congruent. The only way I'm going to be able to do this is if I first show the two triangles themselves are congruent, and then I make the connection between their corresponding parts. So let's look at the diagram. We know two sets of angles that are congruent, and we need to find maybe a side or another angle. Well, there's a couple of ways you could approach this particular problem, but knowing we only have so many reasonings to choose from, like side, 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 angle, side, angle, side, angle, and angle, angle, side, I'm probably going to look for a side here. And I recognize that I have a side in the middle that I can prove is congruent. So my next step, BC is congruent to BC by the reflexive property. Now I have enough information to show angle, side, angle, 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 side congruence. So now I can state that triangle BKC is congruent to triangle CAB by angle, angle, side congruence. If the two triangles are congruent, I am now able to show that side KB, which corresponds to side AC, is congruent. So I'm going to say that KB is congruent to AC by CPCT. In this proof, we are given that BA is congruent to DA and CA is congruent to EA. And we're asked to prove that angle C is congruent to angle E. So the first thing we're going to do is we're going to state the given, and then we start looking for other things we can show are congruent based on one of the properties we know. Well, we should recognize that we have vertical angles here. So our next step, we can clearly state that angle CAB is congruent to angle DAE by vertical angle theorem. If I look carefully at my diagram now, I have enough information to show side, angle, side congruence. So now I can state that triangle BAC is congruent to triangle DAE by side, angle, side, and at which point I am now able to prove or state the prove and use CPCT. So I've shown the two triangles are congruent, so now I can show that their corresponding angles of C and E are congruent by CPCT. All right, in this proof, I'm told that AB is congruent to AC and that M is the midpoint of BC. Let's remember the midpoint because that's a key phrase and we're going to use it. And I'm asked to prove that angle AMB is congruent to AMC. All right, so first step, state the given, and then we're going to look back at the given and try to do something with that key word. If M is the midpoint of BC, that means that BM should be congruent to MC. So we're going to go that route. So step 2, BM is congruent to MC by definition of midpoint. My next step would be to look for any other congruencies I see. Well, I notice that the two triangles share side AM, so I can say that AM is congruent to itself, or MA is congruent to itself, by the reflexive property. Now I have enough information for side congruence. So I'm going to say triangle BMA is congruent to CMA by side, side, side congruence. And then last but not least, I'll state my proof statement because now these are corresponding pieces of the two congruent triangles, and my reasoning is just CPCT. Here we want to name the postulate or theorem that you can use to show the triangles are congruent, and then explain why the statement is true. So basically we're writing a shorthand proof here. So right now I have side, angle, and I probably need another side. So for the first problem, I can prove that TA is congruent to TA using the reflexive property. From there, I've got that the two triangles, triangle, let's say EAT, is congruent to triangle MAT by side, angle, side congruence. Therefore, EA is congruent to MA by CPCT. In the second problem, very similarly, I have two sides, but I know I can prove that JN is congruent to JN through the reflexive property. Now I can say the triangles, in this case, JUN is congruent to triangle, not E, JEN by side, side, side. And therefore, angle U is congruent to angle E by CPCT. All right. Here we're given that KH is congruent to NH and L is congruent to M. And they've asked us this time to not prove something's congruent, but instead to prove that H is the midpoint of LM. So this is a problem that's actually going to go beyond CPCT. But let's first just worry about proving the triangle's congruent. So right now I have a pair of sides and a pair of angles. But as I look at my diagram, I know that I have vertical angles, so I can state that those are congruent as well. So after my given, my second statement will be that KHL and angle NHM are congruent by VAT. At this point, I know that the triangles are congruent. In this case, triangle KHL and triangle NHM are congruent by angle side congruence. Now I start thinking about what the proof is asking me. H is the midpoint of LM. Well, if that's true, and I'm trying to prove that, then I've got to show that LH is congruent to HM. And I can do that now because I can state that LH is congruent to HM by CPCT. And so if those two segments are really congruent and they're a part of the same line, then we can state that H must be the midpoint of LM, and that's the definition of midpoint, because remember, midpoint creates two equal segments. Here we're given that CN is congruent to AO and segment NA is congruent to segment OC. We want to prove that angle N is congruent to angle O. So your first step of this proof, naturally, let's restate our given. From there, we should notice that we have a common side that both triangles share, CA. So we can say that CA is congruent to itself by the reflexive property. From there, we have all three pairs of sides, so that means our two triangles are congruent. So triangle CNA and triangle AOC by side, side, side. And then your last step is to restate your proof, which are two corresponding angles in the two different triangles. So we can state that angle N is congruent to angle O by CPCT. All right, here they tell us that segment LO is congruent to segment MN, and that line LO is parallel to line MN. We're asked to prove that angle MLN is congruent to angle ONL. First step, we're going to restate our given. So we've got LO congruent to segment MN, and that LO parallel to MN, and that's given. Anytime we see parallel lines, we should start to think about alternate interior angles. So if LO is one line, MN is the other, if we go ahead and treat LN as our transversal, we should be able to recognize that we have congruent angles here and here that are alternate interior angles. So I can say in the second step that angle OLN is congruent to angle MNL by AIA, or alternate interior angles. So right now, if I take away all this stuff here, back to our diagram, taking away some stuff, we've got angles, we've got a side, and we need another set of sides. So I know that the two triangles here share a common side, and that's LN. So my next step can say segment LN is congruent to LN, or itself, by the reflexive property. So at this point, I now have enough information for side angle side. So I can say triangle MLN is congruent to triangle OLN by side angle side. And then your last step would be to restate the prove in this case, but this time being able to prove it. So LMN is congruent to angle ONL by CPCT. Since we showed the two triangles are congruent, we can now start pairing up their other corresponding parts.